Good morning, students. Today we start with this topic, vector subtraction. In our previous video, we have learned how to add two vector quantities. And what was the method? There are two methods of adding two vector quantities. One is triangle law, another is parallelogram law of vector addition. Suppose we have these two vector. Say this is vector A, and there is another vector. Say this is vector B. So this is vector A and this is vector B. So we can add these two vector by using these two law. I am taking parallelogram law. So suppose we are going to add these two vector, vector A and vector B, and we get a resultant vector R. So as per parallelogram law, if these two vector represent two adjacent sides of a parallelogram, then the diagonal passing through their common point gives a resultant. For this, let me draw a parallelogram. These are the two vector. So this is vector A and vector B, and with these two vector complete a parallelogram. Then the diagonal passing through this point gives the resultant R. Now if the angle between vector A and vector B is theta, then what is the magnitude of this resultant vector? The magnitude of the resultant vector is R root over A square plus B square plus 2 AB cos theta. And what is the direction of this resultant vector? For this, say the resultant vector makes an angle alpha with vector A, then we can write alpha equal to tan inverse B sin theta by A plus B cos theta. This was the direction of this resultant vector. Now we want to subtract two vector quantities. Suppose we have these two vector, vector A and vector B, and we want to subtract vector B from vector A, and suppose we get a resultant vector R. Now this I can write as A plus minus B. So we are adding two vectors. One is vector A and another one is vector minus B. So if this is the positive direction of B, so this is vector A, so this is vector A and this is vector positive direction of vector B, then what is the negative direction of vector B? So simply it is opposite to vector plus B. So this is the direction of minus vector B. The direction get opposite but the magnitude remains same. Now we want to add these two vector, vector A and vector minus B. So we will draw a parallelogram with these two vector. Let me draw this parallelogram. This is a parallelogram. Now the diagonal passing through this common point gives the resultant. That is, now this is the resultant vector R. This particular diagonal gives the resultant. This is how we are going to find vector A and minus vector B. Note that if the angle between vector A and vector B is theta, then what will be the angle between vector A and vector minus B? It will be pi minus theta. This is the angle between vector and vector minus B. Okay. Now, if we want to find the magnitude of the resultant vector, that is, if we want to find the magnitude of A minus B, here we will just replace the theta by pi minus theta in the previous expression. That is, the magnitude R of this resultant vector is A square plus B square plus 2 AB cos pi minus theta. So it is A square plus B square plus 2AB. Now cos 180 degree minus theta is minus cos theta. So the resultant will be root over A square plus B square minus 2AB cos theta. This is the magnitude of the resultant vector A minus B. Now we want to find the direction of the resultant vector. For this, say the resultant vector makes an angle beta with vector A. So we can write tan beta equal to B sine, now here theta is pi minus theta, by A plus B cos pi minus theta. Now we get B sine pi minus theta, that is sine 180 degree minus theta is sine theta, by this A plus B, again cos 180 degree minus theta is minus cos theta. So we can write beta equal to tan inverse of B sine theta by A minus B cos theta. This is the direction of the resultant vector.